Chapter 5 is the normal distribution. Okay, our normal distribution is very common. We find that the distributions of heights of people, weights of people, tree diameter, scores on tests, repeated measurements of the same quantity, yields of corn, many random variables are normally distributed. Just as a note of caution though, although many distributions are normal, there are still many data sets that don't have normal distributions, so don't start thinking that this works for everything. But it does work in many situations. We also use the normal distribution in many of our statistical procedures, so it's one of the most important distributions that we have. This is the shape. Notice it's kind of a nice bell shape. It's symmetric. The normal curve is centered at the average. And there are many normal curves with different averages and standard deviations. So down here in this picture you can see I've drawn 4 different normal curves. So they all have a similar shape, but some of them are more spread out than others, which means that then some are taller and skinnier, some are shorter and wider. Okay, some of them are shifted left or right, so the shape is affected by both the average and the standard deviation. But they all have the same basic shape, the similar shape, and they share similar properties. One of the properties is a rule of thumb that's very useful, because we found that roughly 68% of the area under the curve is within 1 standard deviation of the average. So again, remember that my average, the curve is always centered at the average, so here's my average. And then if you go out 1 standard deviation in either direction, then the area under the curve is going to be 68%. If you take the average and then go out 2 standard deviations in either direction, then you'll have about 95%. And if you take the average and go out 3 standard deviations in either direction, then you're going to have about 99.7% of the area under the curve. And just as a remark, the total area represented under the normal curve is 100% because the total area under any curve is going to be 100%. Our normal curve does technically extend from -infinity to infinity, but most of the data, about 99.7%, is within 3 standard deviations of the average. Let's put this into practice. So for example 37, we have some facts about IQ. The average IQ is 100. Now throughout the class, I'm going to get in the habit of as soon as I start a problem, I'm going to write the information they give me at the top of the problem, just so I can organize my work better. So the average is about 100 points. The standard deviation is about 15. So the standard deviation is about 15. And then it tells me that the histogram of the IQ scores looks like the normal curve. That means that the distribution of IQ scores is approximately normal. And so I can also say, okay, my shape is normal. And because it's normal, I can use that rule of thumb. So number 1, what percentage of people have an IQ between 70 and 130? So to do that, I'd say, okay, here's my 70, here's my 130. Well, what do I know about the normal curve, and specifically this normal curve? We know that we have an average of 100, and the standard deviation is 15. So if I go out 1 standard deviation, that would be 85 to 115. And if I go out 2 standard deviations, that would be 70 to 130. Because the average is 100 and the standard deviation, the width here, is 15. So for 70 to 130, that's going out minus 2 standard deviations. 100 is the average, and 130 is 2 standard deviations above the mean. So we're looking for the area between -2 and +2 standard deviations. We're looking for this percentage or this area. Now, due to the rule of thumb, about 95% of people are within 2 standard deviations of the average. So if 95% are within 2 standard deviations, and we figured out that 2 standard deviations goes from 70 to 130, then that means we must have 95% between 70 and 130. So my answer on that is 95%. Number 2, find the percentage of people who have an IQ of at least 130. So here's my 130, and I'm looking for the percentage of people that have an IQ of at least 130. Well, 130, that's 2 standard deviations above the average. And I don't know how much is above 2 standard deviations above the average, but if I was to also draw in a negative 2 standard deviations, then I know the area in between is 95%. We also said the normal curve is symmetric, so that means if there's 95% in the middle, then that means there's 5% left for both sides. Because it has to add up to 100%. And then if you divide the 5% by 2, that means you have 2.5% for each tail, or each side. So there's 2.5% here, and 2.5% here. So my final answer, 2.5% of people have an IQ of at least 130 points. Notice the way I'm solving these pictures is I'm solving these problems as I draw pictures. Let me just add a little note here for your notes later. So 95% in the middle means 5% left for both sides. And just as a final remark, the rule of thumb that we just used only works for data that looks like a normal distribution. If it doesn't look like a normal distribution, we can't do it. Now we're going to talk about a very special normal curve. This is one specific normal curve. The standard normal curve is centered at 0. That means the average is 0 and the standard deviation is 1. So it looks something like this. The average is centered at 0. And 1 standard deviation would be from -1 to 1 because the standard deviation is 1. The height of the normal curve can technically be found with this nice looking formula. Don't worry, we're never going to use that in this class. Instead, we're going to use computers or tables to find the areas under the standard normal curve. So this is what the table looks like that we're going to use in this class. It is different than the table in your textbook. The reason why is it's a lot easier to use. It will give you fewer computations than using the one in your textbook. When you look at this curve, or this table, notice that you have the curve and it has this little Z. And then it shaded the area to the left of Z. The standard normal table, the people that invented it, they decided they're always going to do the area to the left of the Z-score. So keep that in mind, it's always the area to the left of the Z-score for the Z table. So what you can do is you can come down and look at one of these specific Z values. So if I was to look up, say, like -2.35, then that means that there's 0.94% area to the left. Or if I look up Z equals 0, then that means there's 50% of the area to the left. And what is Z? Z is the number of standard deviations from the average. Let's practice now actually using our table. So to use the table, we're going to break the problem up into pieces that you can work out from the tables using these two rules. The first one is that your total area under the curve is 100%, so all your areas have to add up to 100%. The second is that the curve is symmetric, about 0. So we'll talk about how to use both of these. Number 1, let's find the area to the left of z equals 1.65. I will always draw the picture, so 1.65, it's a positive number, so it goes on the right side. I'm looking for the area to the left. This is really easy to do. I go to my normal table, and I'm looking for the z-value of 1.65. Oh, here's z equals 1.65. And remember, my normal table only gives me areas to the left, and that's what I wanted. So the area to the left, it says, is 95.05%. So my final answer is that there's 95.05% area to the left of z equals 1.65. Number 2, let's find the area to the left of negative 1.65. Okay, so now here is z equals negative 1.65, and I still want the area to the left. So if I go to my normal table, now I look up negative 1.65, and it looks like the area to the left is 4.95. My final answer is 4.95%. Number 3, let's find the area to the right of negative 1.65. So here's my negative 1.65, but now I want the area to the right. Now the problem is my table doesn't give me areas to the right. It only gives me areas to the left. So if I look up negative 1.65 on my normal table, so negative 1.65 gave me this 4.95. But that's the area to the left. I didn't want the area to the left. I wanted the area to the right. So I can use symmetry. I can use the fact that it adds up to 100% to say, okay, 100% minus 4.95% gives me 95.05%. So the area to the right is 95.05. So that's one method. I could also just use symmetry, and I could look up at number 1. Okay. Notice how this 1.65, all the area to the left of 1.65, and all the area to the right of negative 1.65, those look like they should be about the same, right? And it turns out that they are. They were both 95.05%. Number 4, let's find the area to the right of 1.65. So here's my positive 1.65. I want the area to the right of it. Again, if I look up positive 1.65 on my normal table, positive 1.65, that's 95.05%. But that's the area to the left. I want the area to the right. So I'd have to do 100% minus 95.05% equals 4.95%. So the area to the right is 4.95. I could have also used symmetry, because when you look at number 2, notice that this area to the left of negative 1.65, that's the same as the area to the right of 1.65. And number 5, find the area to the left of 1.8. So here's my positive 1.8. I want the area to the left. So let's go to my normal table. I want z to be 1.8. It looks like the area to the left is 96.41. And that's my final answer because I wanted the area to the left and I found the area to the left. That was pretty simple. Let's try number 6. Find the area now to the right of negative 1.8. So here's my negative 1.8 and I'm looking for the area to the right. Now I could just use symmetry and say I know it's going to be 96.41%. Or I could go ahead and look it up on the table still. So if I look up negative 1.8, the area to the left is 3.59. But I want the area to the right, so I'm going to use the complement rule, which means they all add up to 100%. So this gives me 96.41%. Number 7. Find the area between 1.25 and 1.40. So this is something different. We haven't tried this yet. We want to find the area between those 2 points. So this is what I do. I say, well, if I was to look up 1.40 on my table, let's go look up 1.40 on the table. 1.40, that gives me 91.92%, but that's all the area to the left. So this 91.92 is from 1.40 all the way over. But I didn't want the area all the way over the tail. I only want the area to 1.25. Well, what if I look up the area of 1.25 on my table? For 1.25, the area is 89.44. But that's from 1.25 all the way over the left. So I still don't have what I wanted, which was the area in between the two. So how am I going to find this area in between the two? We're going to subtract. So we just do 91.92 minus 89.44, which gives me 2.48%. And that's my final answer. So again, if you want the area in between two numbers, you just subtract their two individual probabilities, or their two individual areas. And that will give you the area in between. So number 8, find the area between 0 and 1.5. So here's my 0, here's my 1.5, I want the area in between. So again, if I was to look up 1.5 on my table, that's going to give me the area all the way to the left. Here's my 1.5, that's a 93.32. But I don't want the area all the way to the left. I only want the area to 0. So now let's look up 0 on my table. So 0, that gives me an area of 50. So the area to the left of 0 is 50. But again, I only want the area in between, so I will subtract them. So 93.32 minus 50 is 43.32. Number 9, find the area between -3 and 0. So here's my -3, here's my 0, I want the area in between. We just do the exact same thing. First I look up the 0, which gives me 50. Then I look up the -3, and -3 is 0.13. And if I subtract them, 50 minus 0.13 is 49.87%. Notice if you ever try and accidentally switch the order you subtract these areas in, you'll get a negative number. And that doesn't make sense because our areas will always be positive numbers. Our percentages will always be positive numbers. So if you accidentally subtract the wrong order, you should figure it out because you'll get a negative answer and you know you did something wrong. And number 10, find the area between -1 and 1.35. So here's my 1.35. Let's go to my table. I want to look up 1.35. So that has an area to the left of 91.15. And then if I look up -1, that has an area to the left of 15.87. And if you subtract them, 91.15 minus 15.87, that gives you 75.28%. So that's using our normal table to look up areas. Now we're actually going to use it in reverse. So now we're going to know what our area is and try and figure out the z-score that has that area. So example 40, or number 1, find the z-score that has about 65% of the area to the left. So 65% of the area, that's more than half, so it should be a positive number. It should be kind of over here on the right side. And I'm looking for what z-value cuts the curve in a way that 65% of the area is to the left. So we go to my normal table. Now 65%, that's the area. So I'm going to look in the area column for 65%. The closest one I can find is this 65.54% for a z of 0.4. You're not going to be able to get it exact on the table. You could get it more exact if you use the calculator or computer. But for our purposes, this z equals 0.4, that's going to be close enough. So z equals 0.4. Find the z-score that has about 20% of the area to the left. So 20%, that's not very much. We should be over here on the left side. And I'm looking for the z-value. Because we're on the left side, it should be a negative z-value. So we're looking for a percentage of about 20%. It looks like we have this negative, or 19.77 or 21.19. I think that this 19.77 is actually closer, so I'm going to go with that one. Okay, if you accidentally put down -0.8 instead, that would be okay. You would be close enough. If you want to do the average of 0.85 and 0.8, that would be fine as well. But I'm just going to go with the closest one. So z is -0.85. Number 3, find the z-score that has about 15% of the area to the right. This one's a little bit harder because if you want 15% of the area to the right, the problem is our table doesn't tell us areas to the right. So instead I say, okay, if I have 15% of the area to the right, then that means I have 85% of the area to the left. Because 100% minus 15% is 85%. And remember, everything always has to add up to 100%. So now instead of looking up 15%, I'm going to look up 85% on my normal table. So look up 85%. It looks like this 1.05 is the closest. So z equals 1.85. Sorry, 1.05. This is one of the reasons that I draw my pictures, because if I had accidentally looked up 15% instead, I would have gotten a negative z-value, and I would have realized, hey, I drew 15% way over here. That should have been a positive z-value. And number 4, find the z-score that makes my curve look something like this. So there'd be a positive z-value and a negative z-value, and in between there's 80%. So what I'm going to do is I'm going to say, okay, if there's 80% in the middle, then that means there's 20% for both tails. That means there's 10% in each tail. That means there should be 10% in the right tail and 10% in the left tail. So if I was to try and find this z value, there's 10% to the left, so I could just look up 10%. If I look up 10%, looks like my closest is this negative 1.25. So if I look up 10%, z equals negative 1.25. What if I try to look up this value though? This one's a little bit tricky because if there's 10% to the right, how much is to the left? You have to add up all of this area to the left, which is 90%. So I'd actually have to look up 90%. And so z equals, I go to my normal table, I want 90%. So it would be at 1.25. So my final answer is that z is 1.25. Notice you can do all kinds of symmetry on here, because if 10% was to the left and z is negative 1.25, I could have just used symmetry and said, okay, then for 10% to the right, z would be positive 1.25. And finally, find the two values, negative z and positive z, that have 60% in the middle. So if there's 60% in the middle, then that means there's 40% for both tails. That means there's 20% in each tail. So 20% over here, 20% over here. If I look up the 20%, it looks like once again my closest value is negative 0.85. Well, if this is negative 0.85, then this z value has to be positive 0.85 because of the symmetry. And so z is 0.85.